For today's format, we're going to have 3 5-minute lightning talks. So we're keeping it relatively short so that we can have a good amount of time for discussion. We'll take 1 or 2 quick questions after each, but if we don't get to your question, don't worry, because then we'll have a longer Q&A at the end. And the hope with that is also that the speakers can respond to each other. And feel free to post your questions, thoughts, and ideas into the chat as we go. Whoops. Okay. First up is, and I believe I have these out of order. I believe Yves St. James Aquino is going to go first. He is a philosopher and physician, which I think is an awesome combination, with expertise in philosophy of medicine, bioethics, and ethics of cosmetic surgery. He is currently a postdoctoral research fellow at the university in Wollongong, working on the project, The Algorithm Will See You Now, Ethical, Legal, and Social Implications of Adopting Machine Learning Systems for Diagnosis and Screening. So if you want to go ahead and share, Yves, hopefully you'll be more successful than me.
Yeah. All right. Thank you so much, Rachel. I'll just start sharing. Hopefully you can see my slides.
Yes, that's great.
Perfect. Thank you so much. First off, I'm in Darawal country, and the Darawal people remain the traditional custodians of this land. I'd like to thank Rachel and the rest of ADSN for inviting me to speak today. I'm part of a research team funded by the NHMRC, and we consist of different experts from different Australian universities, as shown in the slide. And today I'm sharing some preliminary results of a qualitative study we did last year as part of this project. So in terms of analyzing different views about healthcare AI, we interviewed over 70 professional experts, including clinicians, data scientists, entrepreneurs, and regulators who are involved or are interested in healthcare AI. Many of our participants have expertise in AI and machine learning development, and the rest are directly involved in the implementation, acquisition, or regulation of healthcare AI applications. The question guide covered issues including views about AI development locally and internationally, how AI might or might not change things for clinicians and service users, the key ethical issues and how they should be addressed in practice and in regulation. But for today, I'll focus on views about algorithmic bias. While most participants agree that bias is a problem in healthcare AI, there were disagreements on how to approach the problem. Here, our analysis revealed 2 approaches, which we can view as existing in a continuum, and we refer to them as the narrow and the broad approach. The views of informants who took the narrow approach differed in 4 main respects from those who took the broad approach. First, they conceptualized bias itself differently. They had different explanations of where bias came from, and they had different understandings of its consequences. Finally, they also proposed different solutions to address it. The main difference is that the narrow approach is generally technical and is almost exclusively within the data science domain, whereas the broad approach considers issues outside data science. These are political, economic, cultural, and social factors that contribute to social inequities and health disparities that may be reflected in data and population data used for AI development. Why is the narrow and the broad distinction crucial in understanding and addressing algorithmic bias? First, we believe that differences reveal fault lines between the professional communities working on AI. The significance of this is that people working on AI may be talking past each other or may even reject one another's working assumptions, whether implicitly or explicitly. Second, views about bias are value-laden judgments, and participants may not even be aware of the position that they are taking. What is clear, however, is that their views on the extent of bias, whether narrow or broad, informs how they see their role or responsibility in mitigating bias. For example, some developers strongly believe that data imbalance resulting from unfair health systems is beyond their control. So if you talk about racism, sexism, or even ageism in healthcare systems, that's reflected on data that's beyond the control of developers, and that they are only working with what they have. There is obviously some truth to this, but it merits further unpacking. Finally, the distinction can reveal different points where we can introduce interventions to mitigate or prevent algorithmic bias. While the two positions appear to be vastly different, requiring vastly different experts and expertise, they are potentially additive. Addressing one would help us address the other. At the moment, there are very few people working in the intersections of the two approaches. It's rare for those with technical expertise to be involved in social justice approaches and vice versa. What this means for us who work as ethicists and social science researchers, as well as those of you in the broader data science network, is that there is huge opportunity for interdisciplinary collaboration or cross-disciplinary work. So briefly to summarize, our analysis shows the narrow and the broad approaches are not necessarily mutually exclusive. We believe that they are both important in understanding and addressing algorithmic bias. The bias as understood in the broad sense of being a manifestation of social injustice contributes to bias in a narrow sense, understood as technical errors, and vice versa. Finally, there needs to be engagement among experts working from different fields and domains, and that's why we are very happy to present our work to the Australian Data Science Network. Thank you, and I'm looking forward to your questions and feedback.
Oh, yeah, thank you, Yves. That was fantastic. I wanted to ask if you kind of what the breakdown was of kind of who was subscribing or more likely to subscribe to the narrow framing versus broad framing, and kind of how that varied around any kind of demographic characteristics and also kind of professional training and background, and if there are patterns there that you can speak to.
Thank you so much, Rachel. Firstly, it's a bit complicated with our participants because a lot of them do have multiple expertise. So sometimes there are clinicians who have a background in data science or vice versa. Some regulators are also clinicians, but for the most part, we have seen that developers and entrepreneurs or vendors, CEOs of startups and data scientists tend to lean on the narrow or technical side. Again, we're not saying that when they appeal to the narrow approach, they're not saying that the broad approach is wrong. It's just that they feel that that's beyond their expertise and they're not comfortable speaking about that specific approach. And when you talk to regulators and lawyers, then they're much more interested with what is beyond data science and what are the factors contributing to data imbalance for AI development. Clinicians sometimes go either way. They can be in the middle. They do acknowledge, because they are in practice, they do acknowledge issues of racism, sexism in the history of clinical medicine and healthcare in general. And they do acknowledge that that can be replicated or even worsened by artificial intelligence, but they do not necessarily go extreme in either extremes.
Well, that's great. No, thank you. And then, one more question from now. Connor has asked, more diverse data sets may address inequalities in data collection and be a more broad approach. Would love to hear your thoughts on this.
Thank you so much. So diversity in data sets, as well as creation or reliance on synthetic data sets, have been raised by technical experts. That's one way for them. They feel that can address bias. But the question of what does diversity look like? What does representativeness look like down to numbers? That's a difficult question. Is it about proportion, for example? If you have 20% of African Americans in the US, does that mean that the data set has to have 20% of African Americans? Because every state in the US will have different representation and proportion of minorities. And that's the same question in Australia. So the other issue about diversity in data set, what factors, variables, and even social identities are we going to represent in the data set? Are we meant to have representation of gender, including non-binary, which is still not collected? How are we going to conceptualize racial, ethnic, or indigenous representation? Because those concepts are still being grappled with, even by philosophers. What do they mean? So yes, diversity of data set is a good step forward, but in terms of operationalizing diversity, that still remains to be a live question. And thank you for that question. Thank you.
Yeah, no, thank you. No, this was fantastic presentation and great great answers. And we'll discuss more with the group. Next up is Catarina, and let me just pull up her biography. Catarina Pinto Moreira is a lecturer in information systems at Queensland University of Technology and an associate editor for the Springer Nature Journal BMC Bioinformatics section Machine Learning and Artificial Intelligence. She is a pioneer in the development of non-classical probabilistic graphical models for decision-making to empower human decision-making. I'm looking forward to this. Go ahead, Catarina.
So good afternoon, everyone. So my talk is about a project that we've been thinking about in this last year, and we are starting now to do some, having some results at the moment. So this project is about deep learning and how we classify chest X-ray machines in healthcare. So nowadays we have a machine that consumes an image of a chest, and it outputs you if you have a problem or not. And although these algorithms can be highly biased, they can also be very useful for radiologists. So we can see in many studies that just consuming this image and trying to find out in the pixels of this image and looking for lesions can actually even outperform human experts. But again, when we speak about accuracies, again, we need always to be careful because, again, the algorithm can get it right, but not right for the right reasons, right? So here we go when you try to better inspect these black boxes, because, again, there's a big resistance in healthcare in the adoption of these technologies because they don't understand what they are doing, how they are classifying. And actually, when you compare how radiologists annotate an image compared with how the black box explains you that image, there's quite a big difference because these saliency maps try to be more consumed. They consume more regions and unnecessary things rather than human radiologists that are more targeted specific. So my question in here was, okay, the machine alone, clearly, if we want to promote trust in these machines, it needs to somehow communicate better with the humans and have more targeted outputs as explanation. So can we somehow incorporate human expertise during this classification process? Can we somehow mimic the way a true radiologist assesses and reads an X-ray image? And actually, we've been doing interviews with radiologists for over a year now. And one thing that they told us, the first thing I showed them a machine making a classification was that I don't think that is right, because for me to do my job, I need to know the patient's clinical data, for instance, in order to be able to actually assess if there's a lesion, if there's a scar, and whatsoever. So, and actually there is very few literature supporting this, very few literature investigating the need of these multimodalities in classifications of X-rays. So we decided to investigate patients' clinical data in our projects, as well as a more different approach as capturing eye tracking. So when the radiologist reads an image, it looks at each point, and each point is somehow represents an underlying cognitive process that the radiologist is having or experiencing. And the beauty of what we're finding out is that eye tracking data can actually give us lots of insights about the radiology itself. So it can tell us the degree of expertise. So we have here a radiologist that goes directly to the target point, showing that there's the disease. We have here a student that is looking for the disease and he found it out, but we have also students that couldn't find it. So we can see how expert the radiologist is, how confident in the report he is. And above all, we can extract a cognitive map on how radiologists diagnose these X-ray images. So these are the things that we would like to bring in a novel human-centric AI approach that could probably provide us more targeted explanations. And so we have this hypothesis that combining these eye tracking measures with pupillary activity and clinical data probably can actually mimic how real human radiologists diagnose these images, and probably move towards the well-desired human-centered AI technologies. And we already started to do some experiments with the multimodality fusion algorithms. This is probably what we dream and we aim at, trying to come up with a robust framework that is able to consume different types of modalities of data and been able to generate reports and been able to have targeted detection of the lesions and actually communicate to the radiologist why and the what of that prediction. So what we've been finding so far is that when you have annotations, human annotations, and what we were expecting is that the radiologist would be looking more at these regions where there is a problem in the image. But actually what we are finding is the opposite. The radiologists look at regions where these lesions are not very clear. So what we asked the radiologists to try to describe, because we were very overwhelmed with this, is that, can you explain us why this is happening? And what they're telling us is that we are so used to assess the images that we follow a procedure to assess them. When we see a lesion, we automatically deviate, or that process is disturbed to target that lesion, and that's it. I know it's there, so I need now to focus on parts that I am not sure. So what we are finding out is that actually fixation points in radiology actually can also be a measure of uncertainty of regions that I'm not so certain, compared to other tasks in the literature that have specific goals, and the fixation points correspond to the goal of the task. So other things that we've been looking at is incorporating this clinical information. Can it make a difference or not? We're finding out that it not only provides us better accuracies in terms of the overall model, but it actually can provide better explanations compared to image-only data. Although it's still not the best output, it's still, we can see that it's already providing something. And even here you see that the radiologist was a little bit uncertain, even in certain aspects of these lesions. So who knows that? So this is the dream. We are trying to see if all these multimodalities can actually be a way to incorporate human cognitive maps and how humans assess these images to a novel way of AI technologies. And I would like to thank my PhD student, Richard, for working on this and generating all this data, and my mentor in Lisbon, and also the radiologist group that I'm working on in Portugal, together with a series of people that I've been discussing these issues. So thank you very much.
Thank you, Catarina. That was fascinating. Yeah, I particularly loved how you used the interviews to discover that they're using clinical data, even though that wasn't in the research, as well as the kind of counterintuitive that they're fixating on the parts that don't necessarily have the lesions. Let me just see, I think we got a few questions in the chat. David asked, what is your thinking about the implications? Sorry, it's scrolling as I read. David says, I love the point that fixation indicates regions of uncertainty rather than clinical significance. What is your thinking about the implications of that for algorithms that might seek to learn from gaze data at the moment?
I think this can be a good contribution as a way to develop new methodologies of eye tracking applied to X-ray diagnosis, because we usually see data science, they just consume bulks of data without actually understanding what that data means in the first place. They just wait for the output of the machine to process it. I think this can lead us to new developments of new methodologies to create new AI learning algorithms. I also believe that we can use these uncertainty points to use it as simulations to train young radiologists. Because one thing in the interviews was that the radiologists didn't want the system to complement their knowledge. They didn't want the system to replace their diagnosis, but they were very open to have a system that could teach young radiologists to read these images based on classification patterns from older and more experienced radiologists. So I really think there's a potential side on learning and teaching. Not sure if I answered by
yeah, no, that's great. Yeah, no, and I love that you're referring to the interview kind of feedback again. A question I had was, you mentioned cognitive load and fatigue. I was wondering, are those things that you're able to measure from the eye
Yes.
tracking now? And if so, how do you get that data kind of from the eyes?
Yes.
Or
So,
are you also kind of interviewing the
no, that is actually a standard. So in the literature of cognitive science and psychology, there's a lot of investigation of eye tracking measures and how they correlate with cognitive loads theory. So you can see how the length of the saccades correlate with the focal attention. You can also see going back when you read a text and you go back, that also correlates with some uncertainty. And the microsaccades can also make a measurement of the task difficulty, and blink rate can also give us how tired the radiologists are. So there are mathematical formulas that are able to consume these fixation points and able to come up with an estimate of all these measures.
Oh, neat. Cool.
Yeah.
Thank you. Yeah, so we'll have more questions in the longer discussion, but thank you so much for that. And so next up is Michael Evans. So you can start sharing your screen, Michael. And Michael crafted Australia's National Artificial Intelligence Roadmap, contributed to the development of Australia's national approach to governing autonomous vehicles, and represented Australia at the World Bank IMF annual meetings in Washington, D.C., where he completed a policy fellowship examining the implications of AI and automation for Australia. And so here he is.
Thanks, Rachel, and thanks for the previous two discussions. They're very interesting and insightful. And I think that those kind of learnings also influence what the role of policy is, and it can influence the context in which policy is developed. So today I kind of wanted to just provide a bit of a 30,000 foot overview of what policy is, what it can achieve, where we are today, and then kind of just end with some broader questions that I think need to be asked and are being asked around what does policy mean in the context of AI and in the context of ethics for AI and data more generally. So Rachel already gave me a lovely introduction, so I'll skip that slide. But I guess starting with what is policy, and it's something that we all deal with, but isn't really well defined. And at a high level, policy is just a determined response or position for a given issue or problem, and it usually defines a course of action or principles of action that combines with some instruments to achieve the dedicated outcome. But one thing that I think is important to note is that policy isn't just a government prerogative. It's not just public policies. Organizations and private entities also use policies and procedures to define how they operate. And that in the context of AI, we need to ensure that we're considering not just how public policy is formed and who's involved in those discussions and what the requirements are, but both how that filters down to an organizational or implementation level, as well as who is actually guiding those principles. So policy in general is intended to be designed to achieve a stated or understood purpose. It obviously involves decisions and their consequences. It's generally structured and orderly, but it is political in nature, particularly in the public realm, where differing incentives and positions can alter what a policy position might be. And obviously in the context of ethics, which can be subjective, that has the capacity to radically shape how public policy influences the development of AI and how we manage it on an ongoing basis. So I guess the question is, who owns policy? And I don't think there's a singular answer here. In the public realm, we have government, whether that's local, state, and national. But we also have international agreements, such as through the OECD or the Global Partnership on Artificial Intelligence, that help to derive and recommend actions for AI policy more broadly and with specific regard to ethics. Private companies also have their own internal policies, and I think this will become increasingly important as more and more companies develop, adopt, and use AI systems to achieve whatever their organizational objectives are. And one of the outstanding questions is, how do we embed AI policy and AI ethics into these organizations and ensure that they align with societal expectations? And to date, in an unexpected way, the majority of AI policy relating to ethics is based from government level. However, we are seeing an increase in private enterprise uptaking and creating their own policies to determine what their ethical procedures or requirements might be for the use of AI within their organization. So we all kind of know that policy at the crude kind of level is regulation and legislation, but public policy is actually achieved through a variety of different instruments that complement or can be used instead of legislation. So whether it's advocacy, networking, or telling a narrative, or using the government pocket, government in the public policy space can actually use a variety of tools to influence how AI ethics is conceived, is understood, is implemented, and is adhered to within Australia and globally. So while there is a lot of discussion around, do we need specific regulation? Does the policy just sit within the legislative realm? We also need to consider that policy should also leverage all public tools available to it, including advocacy and networking and telling a narrative, to help guide and inform, particularly the general public who are new to what AI is and are still trying to grapple around with the ethical implications of AI systems, so that they can have an input and understanding of how AI will impact them on their daily lives. But beyond the public policy tools, there are a variety of policy levers and tools that organizations and governments have been using across the world to ensure that AI is developed, managed, and deployed ethically. And these range from being impact assessments to internal and external review mechanisms where there are issues, to risk assessments, to the development of best practice guidelines and industry standards, to introducing recourse mechanisms such as an AI ombudsman or an AI safety commissioner to provide end users, or more generally the public, with an ability to interrogate AI systems and their decisions to ensure that the way they are conceived, designed, and implemented are ethical and did take into account the relevant considerations. And then out of those, we've seen in some areas some more hardened requirements, such as human in the loop requirements, come out for specific systems. So I guess the kind of key question is, what is the role of AI or data ethics policy? And it's an open question because the role of what policy is continues to be debated to this day. But at kind of high level, I think the role of policy in the AI ethics space is to firstly identify, consider, and reflect what we, either as a society or an organization, expect of AI systems in terms of how they are designed, developed, and used, to increase awareness and understanding of AI systems and the associated ethical implications so that we can all better understand how these systems work and what their flow-on effects might be for each and every one of us. Good policy should also help define, guide, and determine how such considerations are embedded into AI systems, or more broadly, the AI development process. And they should help provide the necessary information, guidelines, and tools for AI researchers, practitioners, and users to consider these implications in a practical manner. And one of the things that we've seen recently, and I'll get a little bit into it soon, is that we're very good at coming up with AI principles, but there's an ongoing challenge of turning those principles into practice. And then the final one that I think is a more broad role of AI policy is to provide assurance to relevant stakeholders, and particularly the public, that the AI systems that we interact with on a daily life are conceived of and developed in a manner which is ethical and is aligned to our expectations, and that we can interrogate and understand why certain decisions or certain outcomes occur. So just as a kind of high level insight for those who might not be aware, Australia does have an artificial intelligence ethics framework. It was released at the same time as the AI roadmap, I believe in 2017, and it identifies 8 kind of core principles. One key thing to note about that framework is that it is a voluntary framework for organizations to choose to use, and the government has publicly stated that they will not be making that a mandatory requirement for organizations to use this. And this is an open question of where should policy be voluntary, or where should policy take a hard line and be a mandatory tool or requirement that our practitioners, researchers, and users need to consider. The New South Wales government has also actually taken a bit more of a lead domestically in the role of AI. They have an AI strategy, but they've also recently released an AI ethics policy and AI assurance framework to guide both internal use and sourcing of AI systems and the relevant considerations that they need to make to ensure that those AI systems are ethical and aligned. And as you can kind of see on the screen, the principles are related but distinct. And this is one of the challenges that we have, I think, in the AI ethics policy space, is we have a lot of principles across a lot of layers of stakeholders, be it government or private, that everyone I think can agree with, but there is a lack of alignment there, and that has the capability for gaps to emerge. And then based off this is there's also an OECD AI ethics principles, which Australia is a member to the OECD, which was used to guide, I believe, the development of the Australian AI ethics framework, as well as an additional, I believe, 26 countries. So we can see that there is both state government, federal government, and international government work on the AI ethics policy space. But one of the key challenges is to make sure that those are aligned, to make sure that we that all AI systems meet a common level and a common standard of outcome. And I just wanted to bring to everyone's attention, if they haven't seen it, that the Australian Human Rights Commission did release, I believe it's a 3-year research project into human rights and technology. And they made a variety of specific recommendations to improve the ethics and management and governance of AI in Australia. Not all of them have been adopted. And those can include the creation of an AI safety commissioner, a moratorium on the use of facial recognition technologies, and the required use of impact assessments. So what we can see is there is a broad toolkit out there that we can develop, but we need to mature policy to a level where there is a common set of standards, or at least a framework through which we can understand which frameworks or policies need to be considered for which type of systems. So just before I kind of wrap up, I had a few thoughts on where I think AI policy should go generally, and then specifically in terms of AI ethics. And I think some of these complement the previous two speakers and what we're kind of seeing at the technical level. So AI policy, particularly from an ethical consideration, should span the entire life cycle of an AI system. It shouldn't be a point in time check before it's deployed or a 3-month review after a system has gone live. We need to embed ethics into every stage, whether it's ideating of how an AI system could be used, through to design and testing the system, to deployment, and particularly in ongoing governance. And I think expanding that beyond, I believe, as Yves said, you kind of have the narrow and the broad kind of view. How do we make sure that while the system might meet the requirements that we have at a technical specification level, that we're actually managing and evaluating the ongoing effects that it might be having, you know, on a customer base if you're an organization, or at a societal level if you're a government. To that end, I think that AI policy should particularly focus at the AI application level. So what is the solution, rather than the underlying technology? Because as we know, with the generalizability of AI, some of the key technologies can be used in varying ways. And what we need to do is make sure that the risks of each application are being considered independently, and that we're mitigating those in appropriate means. So while we have kind of seen some improvement in policy, and particularly in ethics, and we are seeing that kind of maturation slowly creep forward, I do believe that we need to kind of continue to mature beyond ethical principles and high level considerations, and work towards providing practical tools and requirements that researchers, practitioners, and customers of AI systems can readily understand and use internally to ensure that they are considering the right ethical implications and considerations. And then, similar to what Yves mentioned, I think in his chat, is policy must go beyond the technical design of the system. And one of the key challenges that we have, as was raised, is we have the technically proficient professionals and developers who focus at the technical level, and we can have some policy guides who look at more of the social impact or the structural reforms that might be required. And there's quite a gap in between, and we need to work better at maturing how these two stakeholders, as well as everyone else, work together to develop effective policy that is practical, that is aligned, and that can actually be implemented. And in the spirit of an open discussion for the remaining half hour, I thought I'd put up a few kind of questions to prod some thinking. And I've kind of highlighted, I think, kind of the main ones that are ongoing questions in this space. So I think it's always important to consider who's being left out of the AI policy discussion. And not just from a stakeholder or a national perspective, but if the nations who are developing the rules for AI policy and AI ethics are the traditional, more wealthy nations who are kind of using AI in a more strategic sense, what does this mean for developing countries? And also, you know, how do we ensure that all communities have a voice and are being adequately incorporated into what AI policy is? There's kind of an ongoing debate in how nations approach this as to whether or not there should be an overarching national AI ethics policy or piece of legislation, such as the EU, or should we merely adopt and adapt existing regulations, policies, and legislation to address AI-specific requirements? And I guess the kind of, in my mind, the meta question that is an ongoing one that we all need to kind of work towards is, how do we create effective policy in a highly technical, nascent, and poorly understood domain? We have lots of expertise at the technical level, and we are improving the distribution of that knowledge and gaining understanding at a policy level, but it is still a kind of somewhat misunderstood or lacking in understanding of what AI is at a policy level. And until we can kind of come over that barrier, it'll be increasingly difficult to manage and develop effective policy. So I'll leave it there. I'll leave the questions up for a second in case any prod your mind.
Yeah, that was great, Michael. Thank you. I appreciated you sharing kind of the tools, both policy tools in general, as well as what tools are being used specifically within AI ethics. I've gotten a few questions, and also, I like the questions that you left us with. Eshnish asked, scrolled. Does Australia have a critical mass of domestic AI firms to be able to enforce policy? Or like many other smaller countries, are most of the AI systems in use developed elsewhere and more subject to local policies, or difficult to subject to our local policies?
I don't know if I'd say we have a critical mass in terms of domestic capability, but I think there is kind of two responses to that. I think generally from a strategy perspective, Australia needs to increase our capability in AI, and we will continue to do that over the next 1, 3, 10, 20 years. But ethics policy and policy for Australia shouldn't just be associated with the development of AI. I think we need to have the policies that make sure that Australian companies who will use AI, be it to be developed in Australia or overseas, do so in a manner that is aligned with our ethical outcomes and what we would like to see. And we have the necessary protections in our systems, because we can't be guaranteed that international companies or organizations will. So I don't think it's about focusing it necessarily at the development stage, even though we need to do that. It's about putting the framework and the guidelines nationally, so that no matter what the system is, no matter where it was developed, no matter who's using it in what way, there is a set of standards, processes, and requirements that all organizations, be they a consumer or a developer, need to work through to make sure that they fully understand their systems and the potential impacts they may have. And then ideally some tools to mitigate some of the risks that might not be avoidable.
Great, thank you. Yeah, then in the interest of time, I think let's move into the group discussion. And I first kind of wanted to give the chance, a chance for the panelists to, or not panelists, but speakers to react to each other. Because I actually thought there was interesting overlap both with Catarina and Yves looking at kind of healthcare applications. And then several people brought up connections between Yves and Michael's presentations on kind of potential policy implications. But yeah, I just wanted to see kind of if any of you have reactions to each other.
Start. Thank you so much, Catarina and Michael. Really interesting work as well. I guess for Catarina, I was wondering if there's a way to capture variability amongst radiologists as well, because obviously clinicians have a different way and different practice, and that impacts on where they are trained, or I guess habits as well. I was wondering if that's something that you can take into account. And then I guess for Michael, my question is whether it makes sense to have an AI regulation that cuts across all industries, when every industry is different. And that's something that we're grappling with in healthcare system, is that how are healthcare applications different from, say, AI applications in financial tech or even in defense? So there seems to be something inherent in every industry that makes the application and the policies relevant to it quite different from others. Yeah, I would love to hear your thoughts.
I can start. So that's a really good question, and something that we also want to investigate. So at the moment, we already made an investment of virtual reality glasses, where we are already building a prototype application where we can already make those studies. We have the data set that we analyzed is from Beth Israel in the USA. We are going to repeat the experiments with the Portuguese radiologists. And hopefully I can also repeat the experiment with Australian radiologists. For what they told me is that in school, they learned that they need to sweep the image to cover all regions, but how you cover them, it's up to you, but you cannot miss them. But it would be very interesting to see how the cultural background and how you learn in your own learning system from your country actually affects also your diagnosis. Actually, at the moment, we are just finalizing one experiment where we compare, we asked our radiologists to annotate the same data set as the one we have from Beth Israel, just to compare if there's a disagreement, because we consider as ground truth what the other radiologists said, and maybe our radiologist might think something else. So yes, we are very interested in checking conflicting diagnoses and see how culture plays a role. And how can we normalize that, or even if it's possible to normalize in a machine. Sometimes it's not, and it's fine. Thank you.
And I think on your question, and it's a good one, right? Do we need a single monolithic framework, legislation, policy for AI in all sectors and all applications? Or do we tailor it to specific industries and we embed it within existing tools? And I think the answer is actually both. I think at a high level, we need to make sure that we can identify, measure, and define the kind of key considerations, be they ethical, be they risk-based, be they some other domain, for the development and use of AI systems. And then what we need to do is take that kind of meta framework and have it be leverageable for each industry. So in healthcare, for example, the considerations might be different because the consequences might be different. So, you know, for example, the bias in data in one industry might have more of a consequence on the end user or on the viability of the solution than in another. So the risks in healthcare differ to the risks in finance than differ to the risks in mining. But I think what we need is the overarching framework, toolkit, and set of guidelines so that you can take an AI system, you can take that framework, and you can tailor it within the institutional knowledge or the domain expertise that exists within that field, and then essentially tailor a micro regulation or a micro policy for that one respectively, because there is no one size fits all. But if we can build a one size that you can change to fit all, that might be a better approach. I will just tack on that one of the more likely ones is that in practical terms, the EU will likely develop some standards and we will likely sign up to them. And I didn't have any questions, but I appreciated both the presentations.
Great, thank you. Yeah, no, and I'm curious to hear how the international comparison goes, Catarina. I think that's a great idea of, yeah, kind of a radiologist in different countries. And we have a question from Vin. While we would like to make the algorithm less biased with a diverse data set, accessing high quality health data is a challenge. Do you think possible collaborations like data sharing between hospitals, clinics, and AI tech firms work? I actually think this would be a good question for Catarina and Yves.
I'll let you answer, Catarina, first, how you manage data sharing.
Yeah, actually, I think there are already lots of willingness from hospitals to share their data in order to promote research. So we see nowadays more and more availability of hospitals sharing their hospital information systems for research and large databases of chest X-rays. So I think nowadays we are seeing more and more interest on those collaborations, and we have access to lots and lots of data sets. Even now with COVID, it's impressive the amount of data that has been shared throughout the pandemic that precisely enabled fast research advancements and finding possible treatments in such a short period of time. And all of that happened just because of this urgent data sharing. So yeah, I think nowadays we are doing that, probably not much as we would like to, but it is happening.
I think from the ethical and legal perspective, there's a lot of challenges when it comes to data sharing. One of them is obviously privacy, but the other one is the federal nature of Australia, for example, because different state will have a different system and different law about sharing. The other question is who owns the data. So are hospitals allowed? Do clinicians own the patient data, or do they only own the interpretation of the patient data? So all the data that involves the physiology of the patient belongs to the patient, but the diagnosis, interpretation, management belongs to the clinician. So these ideas of ownership, you do have to grapple with once you start proposing the idea of data sharing. The third challenge is that there's still not a lot of uptake of electronic medical records. I have heard of hospitals in Australia where they're still using paper to document patient information. So in that sense, you might have asymmetry. Some states or some councils might be overrepresented because they have better digitization of patient data. Therefore, that impacts on the data imbalance that I've discussed as well. But yes, those are just some challenges. And in an ideal world, you have a very ethical way of sharing data, and that there are ways to mitigate potential risks for privacy breaches.
Great, thank you. Oh, David, do you have your hand up? It looks like.
Yeah, just super quick, and it's not a shameless self-plug, but it is relevant. As we get more rich data where we have more categories and more different kinds of individual to consider, we've got an inevitable challenge that this data will become more and more imbalanced, and that creates headaches for biases and so forth. I just wanted to share, I'll share a link to something which can tease apart the balance, the problem of the balance in the initial data set from the performance of the actual classifier. But I think it's an inevitable consequence going back to Vin's question, that as we get more detailed data and higher quality data, these challenges don't go away. They seem to become more confronting. That's all I wanted to say.
Oh, that's great. Thank you. We had a question from Joanna Batstone in the chat. As we engage in research in AI, should we set frameworks and policy regarding who funds the work?
It's a good point. In general, I'm pro-transparency as a policy prerogative. Obviously, in certain domains, that's going to be more consequential. I guess understanding both where the funding comes from, but I guess also where does the data come from? How is it generated? How is it formulated? How is it labeled in which such manner? Because there are also obviously companies, and there's one in Australia, I forget what it's called, who purely exist to generate data for the use of AI systems by global technology companies. So I don't know if it's a mandatory whether we should come in and say every piece of funding for AI systems should be on a public database, but I definitely think it is an area of policy consideration which will probably get more attention in the coming years, particularly as AI becomes more embedded, particularly in our critical industries. I think the risk from AI systems in a cybersecurity sense will also kind of feed into a higher degree of interrogating AI systems or better understanding them for that context. And some of that might flow into the kind of more national security realm of what is the requirements for AI systems which manage critical national infrastructure, how are they developed and who can be involved. That's my kind of 2 cents on it.
Great. Another question is from Ashnish, and this is for Yves. Is the difference between, I think, broad versus narrow conceptions of bias connected to educational pathways? Is this kind of related to scientists being trained to develop solutions quickly for narrower problems, and social scientists being trained to look at broader problems, but slowly and more gradually?
Yeah, thank you so much for the question. I'm not a cultural anthropologist, and it's not something that we were able to investigate in terms of looking at backgrounds, but there are disciplinary norms reflected in the answers and in the approaches. And one thing that I would like to highlight and echo what Michael said, I think the narrow approach and narrow priorities, or the broad approach, we should not really look at them as shortcomings, but more of variations in expertise. And in that sense, we can take advantage of those variations in expertise and just making people aware that these things on the other side exist. So if you have a technical expertise, there are some other non-technical issues that contribute to the technical errors and vice versa. So I think definitely, I'm not sure about the educational background, but in terms of disciplinary norms, there are, you can I guess, extrapolate from their answers and from their technical background.
Isn't that a little bit of prediction bias? Just kidding.
I was trying to avoid that, Alberto. Thank you.
And I had a question for Catarina, which is, have you shown your kind of preliminary results kind of back to some of the radiologists? And I'm just curious if there was anything that was kind of they found surprising or interesting about them.
Well, the most surprising thing was in meeting number 1, where I showed them all, I was selling them all the AI potentials, all these deep learning frameworks, and they just laughed and said, that will never work. So they are very skeptical, which I think it's a perfect research group to work with. If in 1 year time I manage to convince them, I'll already be very happy. So yeah, I feel that the radiologists are very, very skeptical regarding AI technologies. Not sure if it's because they don't want to feel replaced, although I always told them that the goal of AI should never be to replace a human, but rather complement their decision-making power with more information. But they were very, very receptive to the idea of learning. If somehow we can develop these technologies to make simulations, simulate the reading room, to help them, young radiologists, to assess these images. They were very open, and they started to collaborate more with us when we started to sell the project on that one.
As a general note, I had a bit of strategy and innovation consulting on the side, and I would recommend not jumping in with the AI term.
Yeah, I cannot avoid it.
It's hard though, it's hard.
But yes, it was very funny to see how skeptical they were, and they still are throughout the process. Yeah.
Okay, and then David had a question for Michael, referring to Yves' remarks about audiences who have a narrow versus broad focus, asking who do you think is or should be listening to policy here? And I guess kind of, yeah, the role of this narrow versus broad framing when it comes to policy.
The cop-out answer is that everyone should be listening to policy, but that's not very satisfactory. I guess it kind of, and it breaks down, right, what policy and in what way, right? So there's going to be policies, and be they leading to frameworks or considerations that will be more targeted towards the practitioner. There will probably be some that slightly deviate towards a researcher. There will be policies that will be implicated by companies. And so it's not just an individual consideration, it's a right policy to provide the right tool to the right people at the right time. So who should be listening? You know, I shout out about AI from the rooftop as much as anyone else. I think it'll kind of go in stages though. I think, you know, for a natural reason, we start with those who are technically proficient and working directly in the field, who either focus probably more on the organizational or the, I guess, university-based policy and what the internal requirements are, which then feed into and are generated by what's the broader policy at a governmental level or at an institution level or industry standard level. But I think over time, we will kind of gradually see that extrapolate out to more and more stakeholders. I guess you can kind of, you know, expanding circles kind of way from the technical expert to the manager in an organization, to the leadership in an organization, to and with, you know, public and society as we become more educated and more engaged with AI systems. I think policy will mature alongside that to kind of have a targeted focus. But that is one of the key challenges, particularly, is there's a lot of policy and not everyone wants to spend 2 days a week trying to, you know, read all the policies. But I think we should target the policies similar to what Yves was saying, combine them and generate them in a combined way, but also make sure that we do target them in a way and develop them in a way that is actually readily understood and effective. So if you give technical parameterization specifications to the big kind of picture thinking structural person, probably going to be a little bit disengaged, and vice versa. If you go to, you know, your machine learning engineer and say, oh, yeah, but what about the structural reform that we've got to do over here in terms of, you know, the flow on socioeconomic effect? I think he picked up adequately. They're going to go, not my job. I also don't know how I would address that. So there's kind of also a responsibility for universities and research bodies in between that to help develop those tools and skill sets and perspectives to link the two together, I think.
Thanks, Michael.
Great. Oh yeah, thank you. And I'd say, so we're at 1 o'clock now, or 1 o'clock Brisbane time, but we're at the hour. So I just wanted to see if any of the speakers have any final remarks. It's fine if not, but something you didn't have a chance to say.
Good. Thank you so much, Rachel.
Yeah, no, thank you. No, this was fantastic. And actually, let's give everyone a round of applause again.